Hey everyone, YouTube Justin here. I wanted to drop you all a quick little note before we get started for tonight. First of all, it is so good to be back. I am so excited to be streaming again. I did take some time off. It's been a long time since the last stream, but last night was a blast and I'm really looking forward to what I've got in the pipeline for this year. Tonight we're taking another look at the ROP Emporium write4 challenge. So some people pointed out on YouTube and on Twitter that the way I solved it last stream was suboptimal. It wasn't. It was a bit roundabout. I'm still pretty chuffed with what we did. We pivoted up. We pivoted the stack into BSS and then re-exploited. But that time we would know where there is a sh in memory, and away we go. People pointed out that there is a much more elegant writer gadget, which I really should have seen because it isn't a function called useful gadgets. So I probably should have seen that one. So we retool and rebuild the exploit to take advantage of that much cleaner approach. So while we were doing that, we came across something really quirky and really interesting. We were getting strange crashes when we tried to return into system. So now I won't spoil what it was. We eventually tracked it down. Geckham had the right idea for what to do to fix it. And then we spent the rest of the stream kind of hunting down why exactly was it breaking the way that we were doing it earlier. I had a lot of fun hunting that one down, and I hope you enjoy the little tumble down the rabbit hole as well. So before we get going with the stream, a few little housekeeping things. Number one, there's a lot of new and shiny going on. We've swapped the music across to Monster Cat, which I'm really happy about. There's a new playlist full of fresh tunes. I think it's a great playlist and I hope you enjoy it. Second of all, we've switched up the layout, and in general, I've just polished a whole bunch of stuff in OBS. So the audio should be a bit better. The video should be a bit better. Everything should just be a bit nicer. And finally, I taught myself how to edit videos. So now I've actually chopped out all the annoying little BRB segments. So for those watching here on YouTube, you won't have to go scrubbing through those anymore to find out when I get back from making a cup of tea or getting an ice cream. If you have any comments, queries, suggestions, or things that could be tweaked in the stream or on the YouTube videos, please drop me a line on Twitter. My DMs are open, or drop me a comment in the YouTube comments below. I'd love to get your feedback on things that could make this even better. Finally, last night was a lot of fun. There were a lot of new faces and it was so good to meet a lot of you. So thank you to everyone who showed up. If you're interested in trying to catch the stream live, I unfortunately don't have a schedule bedded down for this year just yet. The streams will be kind of coming out as I find the opportunity to do them, but I will be announcing on Twitter as long in advance as I can. Maybe it'll be a day in advance, maybe it'll be a few hours in advance, but I will be letting people know on Twitter, so give me a follow there. And finally, if you haven't already, you should sign up for Twitch, follow the channel, and tick the little box that says notify me when Justin goes live. That way you'll get an email when I go live, and I typically hit the start streaming button about 10 minutes before the actual content kicks in. So that's it from me. I hope you enjoy the stream. Again, we'll be going through the write4 challenge from ROP Emporium, tidying up last stream's exploit and having some fun with a little ret to system weirdness we had going on. So I hope you enjoy it. Good evening, everyone. We are back. New year, new stream. Whole lot of new stuff going on. And it's incredible when you haven't streamed for a while what this does for your nerves. And in classic tradition, my microphone and headphone levels are awful now that I start talking. I swear I'll get that right one day. But so yeah, I'm a little bit shaky, bit rusty. So we're going to have to kind of knock that rust off as we go. And there's something, first of all, there's a lot of new stuff going on. I've kind of rejigged my setup. I got a little bit too bored over Christmas and was really looking forward to being back. So I did my layout all nice and pretty. I'm streaming at a higher resolution now as well. So the text will be a little bit smaller. And I'm not sure if that's going to be an issue for anyone. If it is, please let me know. And we'll see what we can do about the text size so that everyone can appreciate what sort of nonsense I'm up to. Thank you for all the kind words, everyone. Thank you, Dr. Satoshi Cesare. Thanks, Blue Pill, for the audio heads up. At full screen, the text size looks good. Yeah, at Wolf, I'm thinking people might have to full screen things. I used to stream at a low resolution, mostly because Australian broadband. But the side effect of that was I knew that people could see it windowed. But I want to see if people are kind of happy looking at it full screen. But let's just see how we go. Appreciate your feedback, thoughts, comments on the new setup and how any weird bits and pieces are annoying you. So what are we doing tonight? It was about a year ago now that I last streamed, and what we were working on at the time was ROP Emporium. So let's pull up ROP Emporium now. This is going to be a test of my new layout. If I merge these two, will it muck up chat? Fingers crossed. Beautiful. Love it. Love i3. ROP Emporium. So we were looking at ROP Emporium about a year ago, and what was the last one we did? It was write4. I think write4 was maybe the last one we did. Look at this, they've got numbers next to the challenges now, because when we were doing these last year, we managed to do them out of order. We went straight from ret to win across to bad shards and skipped a whole bunch, if I recall correctly. So anyway, we solved write4. I think we were doing 64-bit. And some people kindly pointed out, first of all, on YouTube, Rob Bone pointed it out in the YouTube comments, who said the comments aren't useful. And Hogue said it in a Twitter DM as well, that I had essentially overly complicated my writer gadget. If I recall correctly, and we can dig up, you know what? Let's not dig up that old exploit to start with. To help me shake off the rust, get used to the tool, and get used to the process. Let's see if we can quickly smash through the kind of bug discovery for this binary, and then we'll move on to exploit development. But when it gets to now playing Diablo Wildfire, that might be a problem. I think my now playing script is misbehaving. I'm going to keep an eye. Diablo bad boy. Diablo is the name of my host. Diablo is not the name of the song, so just ignore this little Diablo now playing. I'll fix that up. It wouldn't be new stuff if there wasn't bugs. Hey. When we get to the exploit development phase of this binary, let's flick back to the exploit we wrote last time. Because if I recall correctly, I overcomplicated the writer gadget, and I used a rather large chunk. At Wolf not hearing any background music. Thank you, dude. I'll fix it up in a second. I reused a rather large chunk of the binary as the writer, but it was essentially like half a function, I think. I was just like using an actual like natural function or procedure or chunk of code within a function as my writer. And for example, Rob Bone pointed out that there's some really, really nice little gadgets that can be used as writers to do things like write sh to BSS, and then you win. I'm guessing we were probably returning to system, maybe. But so there's much, much, much tidier gadgets to use than the writer gadget we did use. You're my idol since OzCert 2015. Thank you, jingling your bells. No background music. I'm pretty sure the source is playing. It's probably just too quiet. So let's play the game in a minute, where I turn it up and ask if that's too loud, and repeat until things are good. Jingling your bells. Thank you. I don't remember what I did at OzCert 2015. I'm guessing it might have been the speed debate, which was a lot of fun. All right, let's play the audio game. I'm going to turn up the music just a tad, and we'll see how we go. And you can all say when. There we go. I think I've just added about 10 decibels to the little meter in OBS. Let's give it a second for the latency and the lag and people to make up their mind about how it sounds. I think it's a quiet part of the song. This song here is one I was using earlier to calibrate the audio levels. I think it's one of the loudest songs we get. Just need to get OJ here and it's back to normal. I think at Wolf, OJ might be along later on. He dropped me a line to say that he wouldn't be here for the start. So fingers crossed we get the presence of OJ later. I'm not seeing anything in chat, but how is this for audio levels? Are we still pretty quiet? Let's add another 10 decibels. Any better? Is that any better? We don't want it to be too loud. I did cop some heat from someone on YouTube for having background music. So we want to make sure people can still hear and appreciate and try and mentally tune it out if they can. We don't want the music to be too overbearing. It's about right. I can hear music. Mic audio is still clear. All right, let's go with this. If about 10 minutes in, everyone's really craving some more beats, we'll see what we can do about turning it up. But for the moment, let's leave it here. Let's actually do some computer hacking. Hey, started my recording. Everything is hopefully working. So write4, let's just go to ropemporium.com and grab the 64-bit write4 binary and see if we can remember how to actually do all this sort of stuff. It's been a little while since I've been in the binary tools. Music's a tiny bit too loud. That's not good. Let's turn that down now. All right, let's see how that goes. Let's let that bake for a little while and see how people feel. Thank you very much, Johnny the Ripper. I really do appreciate that. Twitch, ROP Emporium. So what did we do last? So we wrote Pwn write4 64 back in Feb 2018. Damn. All right, so we're going to touch Pwn write4 64 redux.py. It's perfect. Thank you. Now we shouldn't. We should already have. We've got write4.zip here. Show on some of. Actually, let's be adults about this. Let's compare write4.zip to what I just downloaded. That looks good to me. They haven't gone and changed the binary on us in the last 12 months. So I'm guessing that write4 64 from August 2017 is the one that we crave. I know. Well, time for. If anyone got a lead on where 2018 went, let me know. I'd love to get to the bottom of that. It just seemed to disappear, didn't it? Alrighty, so we've got the binary write4. If we run it, what happens? Go ahead and give me the string. Give it a bunch of A's, and it exits. Let's go and open binary ninja. Now, the other thing I did recently was rebuilt this Docker container that I run, or this Docker image that I run my Twitch and other containers off of. Let's see what's broken. I already know that burp is broken in it because the Java's too new. Let's see if we can find out what else is broken in my tool chain tonight. So we're going to do binary ninja on Twitch, ROP Emporium, write4 64. Looking pretty good. Looking good to me. Let's see if we can get these side by side without breaking. That is not what we want. Oh gosh. How do we snap this out of there? Ah! This is going to be interesting while I learn to computer with this new layout. If we do mod E, well, that's something. We got something now. What can we do? What can we do? That's not what we want. That's not what we want. That was looking better. Aha. Now we resize this. And we're cooking with gas. Actually, in 2019 edition, yes. We'll eventually get around to some computer hacking once I stop waffling about my new setup and wrestling with my new setup. Is this where the joke about using a better window manager comes in? It's funny you say that, AtWolf. A friend of mine said the other day, so 2019, hey, tiling window managers, hey, what are we all using to group my friends? And it was just like, i3 still. I started, and I actually went back through my mail spool to find when it was recommended to me to use i3. It was like 2013 or something stupid, I think. It served me well for 6 years, and apart from when you have to wrestle to get things laid out the way you want, because I've got this really interesting fixed width band down the right hand side. Like that chat is actually a window on my desktop, and I've just plonked my camera on top. Sometimes you can hit edge cases and you just brute force your way to getting the layout you want. Left, right, up, down, split it, unsplit it, vertically this, horizontally that. That looks fine. Stop touching it. But apart from that, i3 is awesome. If you're a Linux on the desktop user, I highly, highly recommend it. Let's go and edit that write4. We had pwn write4 64 redux user bin and python2 import pwn t equals pwn.process. So for those who it might be your first time, first of all, welcome. So good to have you here. I love some tools. One of those tools is pwn tools. It's a little Python library that gives you a whole bunch of really nice binary CTF helping goodness. So my exploits are all Python 2. I don't think pwn tools works with Python 3 yet. So I use Python 2 for my pwn tools, and it just gives you so many nice little bits and pieces for running binaries and interacting with them. So we're going to run write, is it write underscore 64? Write4 underscore 64. Write4 underscore 64. So we're going to run that sucker in a tube, and we'll just quickly drop to an interactive shell with it to make sure everything is sane. That's not what I wanted. There we go. So I've got some bad behaviors going on here, but it found it in the end. Give it the string. There we go. Bunch of A's. Too easy. This is something I'm not sure if it's going to work or not, but we'll give it a go. Pwn.gdb.attach. Let's quickly go and attach a debugger to the process and watch everything break. I knew it. So we've had GDB pop, but it's popping out in this little xterm dealy-roo, which I do not want. And I figured out how to fix this the other week, but now I forget it, so I'll probably have to look it up. There's a fork for Python 3, but it's not fully baked. Ah, yes, at Wolf. It's like Unicode, hey? Like, we were all really, really happy with only having 256 different bytes to represent a potential character. Then we're like, half of that will be fine, and we had ASCII, right? Then there's people around the world who are like, I don't speak English, and we're like, ASCII. But it's amazing what little pictures on mobile phones and emoji did for making the world adopt to supporting Unicode. So yeah, now because Python 3 treats Unicode as a first world citizen, it makes it really confusing times for exploit developers and CTFers when they're like, I just want characters as bytes. None of this fancy things with characters with accents that make it double or quadruple the width of a byte. I don't really want any of that. So I wouldn't be surprised at Wolf to know that, yeah, pwn tools is likely having some issues living in a bytes world in Python 3. I had to set the context the other day to get pwn tools to stop popping GDB in a separate window, and I tried to track it down and I couldn't find out when pwn tools changed its behavior, but like, fair enough, they prioritize the fact that display is an environment variable and it wants to pop a new X term. They prioritize that over the fact that I'm inside tmux. Find .-name GDB pwn lib/GDB. So I'm just going to jump into the pwn tool source for a second to remember what it is that I had to do to fix this. Let's look for attach. Def attach. Where are we actually running the debugger? misc.run in new terminal. There we go. And it's choosing the wrong terminal for me. Pwnlib util/misc run in. Here we go. So what I need to do is set context.terminal, and the first element in that list has to be tmux, and then the rest has to be split w. Right, context, pwn.context.terminal equals, I think will do the trick for us. pwn.context.terminal is a list of tmux split w. If we do this, and hopefully pwn write, nope, pwn write redux, hopefully this will pop GDB inside tmux for us. Well, hey, there we go. So now we actually get, oh man, if I full screen, that's not too bad. That's how we used to roll. Covers up chat. Cool, so we get pwn tools, pop and GDB in our tmux. That just makes things a little bit nicer, I feel. All right, so now what we're going to do is t.sendLine a bunch of A's and see what happens. So buff is empty string, and then we'll pen to buff 1024. We should probably actually look at the, I don't know, disassembly. So it does a puts of go ahead and give me the string, then it calls printf, then it calls fgets. Man of fgets, what does fgets look like? Takes 3 arguments. So we're shoving stuff into local variable 28. We're doing OX200 bytes from standard input. So there you go. Here's the function signature of fgets, and you can see here, before we call fgets, we're populating the good old RDI, RSI or ESI, and RDX with the parameters. So we're slurping up 200 bytes, OX200 bytes from the user, from standard in. Although weird things might happen. I think the OX200 byte will have to be, yeah, it will be null. It null terminates for us. And the new line, I'm guessing the new line, I can't remember how fgets works. If new line is read, it is stored into the buffer. Okay, gee, man pages. Who would have thought that they would, that'd be so helpful. So we're going to pull in OX200 bytes from the user, which may end in a new line, but it will definitely end in a null byte, and sticking it into variable 28. And I guarantee variable 28, it's not OX200 bytes large. And there's our overflow, right? So when we go and shove up to OX200 bytes in, which we will do, OX200, we'll smash a lot of things. We'll smash the save return pointer of this stack frame, and then all the way down the stack. So we've got pwn spinning up GDB, and we're sending a line of buff. Let's go run that one. Oops, we didn't continue. We'll have to fix that. And here we go. Segfault, rips pointing at a ret. And the top of the stack, and the whole stack, in fact, is a lot of A's, just as we expect to see. So at this point, we've got control of rip, because when this ret is executed, what is at the top of the stack will essentially be popped into rip, and it'll then crash because it tries to execute OX for one, which isn't mapped. But that's actually not why it's crashing now. Why it's crashing is because, as per the name of the challenge, it's ROP Emporium, we've got NX turned on, which means that because a whole bunch of A, I mean, you see, actually, you know what? I might be wrong here. I don't know if it's 64-bit crash. Does it always look like this, where it crashes on the ret? I think it might just be a 64-bit crashes on the ret, and a 32-bit crashes after the ret. You know, with this actually having for one in it. But irregardless, respectively, even if we could go and ensure that a valid pointer to something we control was returned to, NX would ruin our fun. It would prevent us from executing, say, the stack. Multi-hey dude, good to have you here. Welcome. I had some fun issues hashing data from Windows 16-bit characters. Yep. Every character null between them hashes differently than just the string. Yes, funny that when you go and change the string by sticking nulls between every other character, or between every character, it will be different data. Yay for Python and encoding. I know, right? And by the way, people who are wrestling with Windows binaries and trying to strings them to find the flag in CTFs, if you run strings on something that's got Unicode in it, strings won't find very many strings. Just a quick tip that strings allows you to supply the encoding. I think it is -- encoding. So you can say that it's ASCII, it's 8-bit characters, it's 16-bit big endian, 16-bit little endian, so it's useful for finding wide character strings. So if you're ever stringsing a Windows binary looking for a flag, and the flag is a Windowsy Unicode string. I can't remember if Windows is little endian or big endian, but hey, strings has you covered. You can use strings to discover Unicode strings in binary files. Little tip for you. So let's go and just quickly nail the exact offset to the bunch of values we're trying to return to. We'll do this. We'll get rid of that there. We'll go buff plus equals pwn.cyclic of OX200. And what this will do is, for those who haven't seen this before, pwn.cyclic of 100. Can't type. It essentially prints out a non-repeating string of characters such that any consecutive 4 bytes in here, for example, these 4 bytes here, aka A, won't appear anywhere else in the string. So if you're then like, well, I know that like 1, 2, 3, 4, these 4 characters got put somewhere interesting, like some register or into RIP or something like that, or EIP, sorry. There's a little trick if you're doing 64-bit exploitation. Then you can do pwn.cyclic find of that, and it'll tell you the exact offset into this deterministic non-repeating string that it appears. Now, what you'll want to do is if you're doing stuff on a 64-bit binary, the default for cyclic is n equals 4, where every 4 contiguous characters will be unique. Won't do us that much good in a 64-bit world. We want every 8 contiguous characters to be unique. And there we go. So you can take these 8 characters here, and they'll only appear once. 4 would probably... 4 mostly does the trick. If you forget to do this, things normally just work. But hey, if you're going to go being like, hey, I got this 8-character thing, where did it appear in my cyclic pattern? You probably should generate a cyclic pattern where n equals 8. So let's do OX200 bytes with n equals 8 of a cyclic pattern. Run that bad boy. Oop, you know what? Let's just quickly fix this up. GDB is waiting for us to do stuff, but we don't want it to pause for us. Let's go GDB CMD is a list where the only element is C for continue, and attach takes a parameter GDB script, and it's a new line separated list of the script that it should run when it starts up. So we'll use new lines to join all 1 entries in our GDB CMD. And what that does is tells GDB, go ahead, execute the binary. We don't need you to stop so we can set breakpoints, because we will set breakpoints ourselves later on by doing things like break main and actually adding items to our GDB commands list, which then get new lines separated and fed to GDB so it can do it upon starting. So we just set GDB CMD to be C, just so it's like GDB, go and do your thing straight away. We don't need you to wait for us. Let's run that, and we should get a crash. Here we go. So the first 8 characters are F, then a bunch of A's. So we know that the ret, if it was to be executed, would return to the address that is FAAAA in bytes. So we've got our offset essentially. Once cyclic find goes and finds where that would normally appear in the string, we have our offset. So our offset to the save return pointer is pwn.cyclic find of that string where n equals 8. If you're going to go give n equals 8 in the pwn.cyclic, you got to do it as well in the cyclic find. So now what we'll do is we'll go chuck a whole bunch of A's in that take us out to the length, will take us out to the offset that we have just discovered. So we'll do offset SRP minus len buff. This is another pattern that I use quite a bit, these simple overflows. Offset SRP will start off, pwn.cyclic fine. This returns a number, by the way, just so we can see what's going on there. Python 2. Whoops, where's chat? There we go, there's chat. Auto mod held a reason. Allow, we'll post it to chat. Not multi. Multi maybe you're a mod as well. Menstrual. Brendan, can you check out what auto mods on happy about, please? If we import pwn and then do pwn.cyclic find of our FAAAs, that n equals 8, we get 40 back, right? So it's 40 bytes into our string of OX200As that the offset to the SRP is, or the SRP overwrite is, right? So this here returns a number. Come on, there we go, returns a number. And then what we do is we do A, and we want 40 of them to take us out to the offset at which we're performing an overwrite, right? But I just do this little cheeky minus the length of buffer so far. What it means is later on I can go buff plus equals BBBB for some reason. If I wanted to start my bunch of A's with a couple of B's, this would just go and work itself out. It dynamically updates so that we're always writing the exact number of A's. Right, Atwolf? Good times. We do not speak of that. We do not speak of that event that I got mostly flustered at. Anyway, we got a whole bunch of A's, and then we're going to just go buff plus equals. Actually, you know what? Let's be tricky. Let's pack 64 of OX dead beef decaf bad. Let's go and pack ourselves a 64-bit pointer as ASCII, and go and whack that after a whole bunch of A's. And then we'll go buff plus equals. Let's quickly just go into a cheeky buff total length is OX200. And then here we'll just quickly assert that the length of buffer is less than or equal to that. So what this little assert does is if when we get to this point, the length of buffer is greater than OX200, we know we've overshot the fgets that is going on. In fact, it'll have to be that -1. No, it won't. Yes, it will. Yeah, because the last byte's going to be a null byte, right? So we'll just do a cheeky little assert to make sure we haven't blown our budget on too many A's. And then we'll just go buff plus equals a bit of trailing garbage to take us out to the total length. Let's go buff total length minus the length of buff so far. We're just going to pad it out with Zs so we can just maintain that exact length of string. We're going to shove that down the gullet of the process and see what pops out. I'm expecting to see a crash with the top of the stack being dead beef decaf bad as a pointer. Let's see how we go. Looks good to me. Rip is pointing at a ret, and the top of the stack is pointing at OX dead beef decaf bad. So at this point we do tightly control rip, or the instruction pointer, and now we need to ROP to actually get code execution. Oh, well, it wasn't using n equals 8 last time. Yeah, I know. That's something I've learned to do. Need to make a buffer overflow. Brendan, I've made one like that for you, didn't I? I think, or at least I think, Brendan, I think I made you a challenge one day that like had capital A as a bad character or something like that, or just acted funny when you fed it an A. You're right, it is too mean, and I was too mean to Brendan, and I have no regrets. Yeah, Goldilocks, that's right. That was good times. We should probably crack them open on stream sometime and reminisce about the good old days, Brendan. All right, so we've got a nice tightly controlled save return pointer overwrite. We now want to ROP our way to success. Useful function, useful gadgets. This rings a bell. This is what Rob Bone was saying on YouTube, I was thinking useful gadgets may have been a heading in ROPA or ROP gadget. No, ROP Emporium have gone and actually in useful. Okay, so useful function is a function that does system ls, and that will get us appointed to system. Is it implemented? No, it's just dynamically linked in, so it's in the GOT. So we've got system as a function we can call, and useful gadgets. Move what's in R15 to what R14 points at. There we go. That there is just a really nice little writer. Let's quickly have a little look at what we did last time. Hey, let's have a look at the monstrosity of a ROP chain that I built last time. I have not cracked this open in a while. Rob Bone and Hogue on Twitter hit me up pretty quickly, and I was like, the shame. And I haven't looked at this exploit since. Let's have a look at the Pona. It's a nice little short exploit at least. What have we got? We've got a pointer to fgets. We've got a pointer to system. We've got a pointer to some area of memory that's writable. We'll be going through all this shortly, but in a more coherent manner this time. We've got a pop RDI, a pop RSI, which also pops R15. Gee, that looks handy. And then a pop RBP. Right. And we've got a gadget, which I called fgets. Can we just go here in Binger? So it moves the pointer to standard in into RDX. Oh man, what did I do? Ugh. A valid jump the pointer that the pwn cyclic lands. Atwolf, if you're going to do that, make sure you do it for Metasploit's pattern create as well, because they are different algorithms. So what was my old gadget? Move stood into RDX. It moves a stack address to racks. Oh, what was I doing? And then it moves OX200 to ESI for the length. Then racks, racks goes to RDI and then the fgets. So what did I do? Had a bunch of A's. Aha, then I popped RBP. Aha, yeah, because this stack address here is calculated based on RBP, right? So I took control of RBP. I hijacked RBP, pointed it 20 bytes past where I wanted to write to, and then I just jumped straight back into halfway through the pwn function. Is go and do the read again. Except this time I've done a stack pivot virtually. I pivoted the stack up into, I'm guessing BSS. I'm guessing this address here is in BSS. No, dot extern. Which is fine. I'm guessing it's writable. Anywho, I then use that to write to this address. Yeah, that plus 20 would mean that this then takes the 20 back away. So I sent that down the gullet. And the pointer to my shell is the pointer to writable plus the offset to the save return pointer. Plus 4 times 8. What was I doing? Didn't I run something funky last time? Yeah, at Wolf, I was probably doing VM map. Yeah, Brendan's on it. I was doing VM map inside GDB. We'll be doing that shortly. We'll likely play around with VM map later. That was the first buffer. So I did one save return pointer overwrite the way the binary intended me to. Stack pivoted up to somewhere writable. Aha, and then I basically did the exact same thing again, right? Or almost the same thing. No, nothing the same thing. Basically did another stack buffer overflow up where the stack was never meant to be. another save return pointer overwrite up where there's not meant to be any save return pointers after we did the stack pivot. The chain this time looked like a pointer to pop RDI, which would pop the address of shell into RDI, because this here is the pointer to my shell, which is this here, inside this second buffer. So I popped that into RDI, yeah, because RDI is the first argument on a 64-bit function call. And I just dropped in the pointer to system in the PLT. And then I just crashed. I was like, this process is beyond saving. Wow. Yeah, that was certainly innovative of me. It worked, but it's not elegant, is it? It's not as elegant as, oh, I don't know, using the useful gadgets to actually write stuff more surgically than just being like, I'm going to reuse the vulnerable function, except only half of it once I've done a stack pivot. All right, so what we're going to do tonight is we're going to basically rework a new ROP chain that uses this more elegant gadget to do our write where to set us up for success. The reason I did this, I wanted the shirt to be somewhere predictable, because obviously the stack is going to move around due to ASLR, and even without ASLR, I call it nature's ASLR, where like the size of the environment will basically change your stack base. We had no way really of reliably predicting where the sh was going to be on the stack. So I did a stack pivot to a predictable known location, which was writable, and then I would know exactly where the sh was in that second stack buffer overflow. But let's not do that this time. We'll do it more neatly. I'm going to take a quick 5-minute break. Please take the opportunity to do so. Grab yourself a glass of water. It's pretty warm here in Australia at the moment. If you're overseas, it may not be so warm. Grab yourself a cup of tea, hey? But we'll reconvene in a few minutes. Alrighty, we are back. Managed to do some weird stuff in Vim while I was away. I capitalized some stuff randomly, or yeah, that was before I left. Yes, Atari, wrong channel. I don't mind a cuppa from time to time. I'm more of a whiskey guy these days. Well, lately I've been hitting the whiskeys, but the weather's just. OJ would, thank God he's not here, not be happy to hear me say this, but it's too hot for tea. It's just too hot. And a high % dark chocolate, that's right. What a legend. Hopefully we can catch him shortly. Alright, so we got this nice tight control of RIP. We've got a nice little assertion to make sure we don't blow our budget. Looks like we won't. We had a pretty short ROP chain last time. And some good old trailing Zs. So just once more, if we run this here, we see that we crash on a ret with dead beef decaf bad being pointed to, and a whole bunch of Zs after it. Can't have regular tea, then you need iced. I should make thank you, Atwolf. I've been making some cold brew iced coffee, but I need to make some iced tea. You're absolutely right. A, it's a bit too late in the day for cold brew coffee now, and B, I'd be bouncing off the walls and up all night. But I should make some iced tea. Bloody good idea. So now let's use our mod. Let's call this let's call this one here. Let's just quickly note this one down. Pointer to elegant writer. Much better than our previous writer. Let's copy the address of this here. There we go. And we'll just quickly note down what it does. Can I just copy this here? Can I copy? Thank you, Binary Ninja. How do I copy this? How do I computer? How do I copy this block? Where are we? Can I copy this here now? That's not what I wanted to do. Thank goodness Binary Ninja has an undo option, am I right? Let's copy this. Ah, goodness. It's not going to do it for me. I'm sure there's a way to copy that. That sounds really nice, that Wolf. You got me jealous now. Hey, Geckham, how's it going? Good to have you here, dude. So we're going to move We're going to move to R14 from R15. Not at all. That will confuse me later. I'm going to move the keyword R14, R15. That's what we got. That's our elegant writer that we're going to use this time instead of the god-awful thing that we used last time. Let's go and jump to Twitch, ROP Emporium. Let's run ROPper against this, which I'm sure we would have done last time. Is it -F for ROPper? -- file. So I'm going to run ROPper against the file write4 64. Do we need to turn color off to get clean output? Can we just go and -O ROPper? I want to write a text file full of my gadgets. No, let's just do -- no color to be safe. And redirect that to, what did I call them last time? Bad chance calling me. Had a session, that's fine. Pone. I didn't save my gadgets last time by the looks of it. Write4 64 gadgets from ROPper.text. So what does that give us? It gives us a text file with all the pointers to all of the potential gadgets. It's not that long of a file. Now the moment of truth. I mean, I really, last time I did this, should have seen this useful gadgets function with this delicious writer in it. But was this writer picked up by ROPper? Guessing it probably was. Copy the address. Search for it. There we go. Really should have seen that. Did we have any other gadgets I should have seen last time? Let's go to the top. Add. I mean, some of these you can. That looks awful. Some of these you can sometimes use, but we've got adds, we've got calls, we've got ands, calls, weird stuff. So we could have moved EDI to what RSI points at. That would have also been probably nicer than what we did, provided we can find a pop EDI and a pop RSI. Oh, that's only moving EDI, so you're not moving the full width. 64 bits there. What other moves do we have? Looks to me like this is the golden one that we should have found. Probably could have used that one anyway. All we want to do is write null byte somewhere. But yeah, that looks good. I think we really only missed one nice gadget. Let's just grep for mov in that file. It's like all these here where you move a constant value into a register. That's not that interesting. We're going to grep for mov, and then on the same line we want a square bracket so that we can do like a write to a destination, not just write into a register. So we've got a reader here where we can move the D word pointer that Rax points to into EAX. Here's our delicious gadget, I'm guessing. Yep, that looks familiar. So we've got a reader here. Got that there, but again, that's not the full 64 bits. That's our delicious one. I think we only missed one in our ROPper output, but that's no excuse because I should have seen the useful gadgets function anyway. Hey Volko, it's a Justin, indeed it is, and it's a Volko. How's it going? This is ROP Emporium. Yeah, you can get cold brew in a cup. That's cool, Splat. That's really cool. Is bin shit in the app already? I'm guessing it's not, but that's actually a really good question. Guessing it's not, because if so, this wouldn't have needed any sort of writer gadget at all. That's a really good question. we find... No. Raw string? No. What has been Binary Ninja found for me? $56.41. Oh, you know what? I've probably got to turn off case insensitivity. Hex 56. What are you doing? Escape string for text search in Ninja. Thank you, Geckham. Do I know about Kali Linux? Yes, Lion Central, I do know about Kali Linux. Is that all you were curious about, Lion? Am I going to DEF CON this year? Probably not. Probably not going to DEF CON this year. Escape string for text search in Binger. What is this? What is this control F for? Is it raw string? Text? It's finding all the pushes. Find next, F3. Yeah, look at that. It's finding all the pushes. Constant ship isn't going to help us, I don't think. Escape string of like capital A. This is finding us. It's finding us case insensitive ones. Yeah, so that's how you find your bytes. 41. So if we search for a case sensitive S, look, I'm guessing there's no shs in here. And we also grep sh in write4 64, and it matches. There's two shs in write4 64, but that might just be part of like the file metadata. Not actually part of the binary as it would exist in memory. Write4 64. Look for sh. Oop, less that. Look for sh. Yeah, there's all these here, but you know, I don't think you actually see things like GNU hash in memory once it's running. The last thing we can do to check is to crash it. And then to use find, yeah, in memory. Here's your VM map at Wolf. This is probably what you were thinking last time for finding writable parts of memory. So if we do a find for sh, starting there and ending here, that should be searching kind of memory for sh within the space of ROP Emporium, which by the way doesn't have ASLR turned on. Yeah, no shs actually in memory. If there was Geckham, if there was a sneaky sh in there somewhere, that would completely break this challenge, I think. It basically just becomes like a stitch your registers up and return to the system. Is there a system call? Yes, there is. Geckham, there is a system call. They've given us useful function with a call to system, which gives us system in the GOT and in the PLT. Sorry, Lion, what's going on? You're having a huge issue with Hashcat. You don't have a native Intel CL runtime. I don't do password cracking, sorry, Lion. Hopefully there's someone giving you a hand. Volko's. Interesting, Lion Central. Obviously, if you're using Hashcat, you almost certainly want to be having a GPU available. If you're running it in a VM, you almost certainly want to be passing a GPU through to it. Lion, Volko, hopefully you guys can sort it out together. Multiplexers, right? Run it on the metal. Run it on the metal, indeed. Yeah, we're going to have to inject the string somewhere ourselves. Ah, okay, yeah, Volko, yeah. Look, I'm going to leave you guys to it. It sounds like you're hashing it out fairly well between you. So we've got our elegant writer, which is going to move what's in register 15 to where R14 points. And we've also got a text file full of gadgets now. The gadgets are from ROP. So we need to find a pop R15 and a pop R14. Where was that grep? Not there. There we go. Pop, what did I say? Pop R14? So here's one here. We've got a pop R14. Pointer to a pop R14 equals that. We need a pop R15. We're going right there as part of... that's beautiful. We want control of these two. There's a pop R14 and it contains a pop R15 naturally. But just in case we need to pop R15s ourselves, we may as well go and grab one. Here's a pop R15. There you go, it's actually part of the same gadget. So we've got control over those. We've got gadgets that'll give us control over those two registers. What else do we need? We need the pointer to system at the PLT, which is this here. So we'll copy that address. So these here are our gadgets. Here's our pointers to other stuff. Pointer to system at the PLT is that there. So we can, what do we want to do? Let's get rid of that bad boy for now. ROP chain is, we'll come up with an empty list to start with. And then we'll go buff and we'll append everything in ROP chain. We probably want to map P64 over that ROP chain. How do we do this? Python 2. Is there a map function? Yep, map a function over a sequence. So if we've got like import pwn, let's say our pointers is 1, 2, 3, 4. We should be able to map pwn.p64 across those pointers. And there we go. See what's happened here? We've got a list of pointers, very, very small pointers. We actually map this magic P64, like this pointer packing function, over the top of P, and out pops a list where every element has had that function run over the top of it. Really nice way to quickly, you know, pointerize all your stuff. But do we want to pointerize everything? Not sure we do, so maybe we won't use that. We'll actually go and put the P64s in the ROP chain. I think that's the safest thing to do. We're going to have sh in there somewhere, and I don't want to have to unpack that and then repack it. So we're going to append to our buff an empty string used to join the ROP chain. It's getting a bit complicated. We don't need to be that special, I don't think. ROP chain. Buff plus equals. We can just go and build up our ROP chain like this. So we want to move the string bin sh, or even because it's system sh would work. We want to move the string sh to somewhere in memory. So we need a writable pointer. Let's go and get ourselves that now. Let's go and make this crashy again and run it. Here map. So here's a writable page, 601.000. So 601.060 is the BSS. We've got some stood in, stood out, stood out. We probably don't want to smash that in case they're important. Am I missing anything in chat? If there's anything in chat that needs my attention, everyone, please give me a shout. But otherwise, it looks like you're all discussing Hashcat, which is totally cool. Go for gold. Okay, so it's 601.089 BSS ends. 601.078. This here looks like plenty of room to write shit to me. So we'll use this address here as our writable. Pointer to writable. Use that. So let's just go and quickly have a quick play with this. I'm going to set a breakpoint just quickly on the crashing ret. Just so we can step through our ROP chain. Alright, so GDB will stop at our ret even if there's a valid ROP chain on the stack, so we can step through it. It's not at all what I want. Buff plus equals pwn.p64. Let's go and pack this bad boy here, the pop R14 and R15. Let's just go and actually put that in there so we know that it does both for us. So what are we going to put into R14? R14 is the where of our write what where. So let's go and pop into it the pointer to writable. Buff plus equals pwn.p64 of the pointer to writable. All right. And then we're going to pop into R15 the what. Buff plus equals pwn dot. Let's go unpack 64. When you do pwn.unpack 64 and give it a string, which must be of length 8, it'll pad that string out to 8. L just, is it? There we go. If we go and wrap this up in a hex, we've got a whole bunch of spaces, and then our A. If we go and unpack A, B, C, D, then we get A, B, C, D. And I think when this gets as a pointer, that pointer there, once it gets written to memory, I'm pretty sure will look like A, B, C, D. But you know what? Let's find out. Let's go and grab this actual unpacked A, B, C, D and just drop it straight in here. So what are we doing? Into R14, we pop the where, which is the writable, which is 601.078. So this is the what? No, it's not. Not even close. This is the where, and this is the what. As long as we then put onto our ROP chain buff plus equals pwn.pack64. What am I doing actually putting a integer in my ROP chain for? That's not right, is it? That's not right. It should just be a string. Our ROP chain, our buffer is a string, so we just literally want it to be ABCD and then just pad it out with nulls until we get to the length 8. Yeah, that should be right. That should be right. Then we want to go and put our elegant writer gadget there. And then we want to go and put our, let's go and pull our dead beef decaf bad down to here and we'll get a crash. Geckam spaces will work, same as nulls, it's a command. Yeah, true, but Geckam, if we're doing a system of sh, then a bunch of spaces as a null, non-null terminated string, I mean, yeah, there are nulls hanging out in memory here. 1, 2, 3, 4, 5, 6, 7, 8. This std unsigned integer won't necessarily have a null at the leftmost edge of it when it's in memory. So we may have an unterminated string, and so we may do a system of sh, whole bunch of spaces, and then garbage. That's what I'm worried about. So I'd rather pad it out with nulls. I think nulls are cleaner. I think you're right, Geckam. It's getting dark here. I think my camera's starting to get a bit blown out. Just turn this light down a bit. That's looking better. I also now don't have a bright light shining in my face. So what are we going to do? The where goes into R14, the what goes into R15. We've got a pop, and then this gets returned to, which is going to move what's in R15 to what's in R15 to where R14 points at, and it's going to return. And we're going to get a crash on our dead beef decaf bad. And we should hopefully see ABCD be put into memory at an address we control, which will be the writable address. Let's see how we go. Alright, so we actually hit a breakpoint on the return. I set a breakpoint there so it wouldn't run away on us. So if we examine one string at that writable location, we get empty string. That's what we expect to see. Or I wouldn't have been surprised if something had gone and put something there. But it's this address here. Doop doop. That's not what I wanted. Can I? No, can't shift select that. Anyway, if we let GDB continue, we then get our crash with a ret to dead beef decaf bad. But if we examine the string in memory, then we get ABCD. So we've now gone and put our own string into a memory at an address we control. You know what? That there is so much nicer than what we tried to do last time, isn't it? Last time we had two separate buffers, one getting fed in after the other, and a stack pivot, and now we've got a really nice clean writer. Geckam says, why not overwrite binls and call useful function plus offset? That'd probably be a smart thing to do, wouldn't it? Same. Yeah, you're right. I mean, this binary is already very artificial. They've given us these two very useful functions. One of them is called useful function, one's called useful gadget. Is that a read-only string? Might be a read-only string. Yeah, it's in RO data, Geckam. So if we tried to spike that ls there, it won't be in a writable area of memory, and we'll get a crash trying to write to it. I suspect. We can give it a go though. Can't hurt, hey? Let's copy the address of /bin/ls and see if we can go and put lay some ABCDs down over the top. I'm going to be really cheeky here and change the where. I'm just going to drop that in there temporarily. Thomas Bra, this is as legit as it gets. Welcome to the channel. So Geckam, I'm just going to go and drop the address of binls directly in the middle of my ROP chain. Haven't given it a nice name. I'll just put it in there. So if we run this, we should hit our breakpoint. Yep, hit our breakpoint on the return to pop R14, which is going to be the address of binls, pop R15, which is our ABCD. And then we've got our elegant writer. If we continue, then yeah, we get a segfault on that elegant writing instruction. So we get a segfault because we're trying to write to a read-only address in memory. Menstrual, no, not writing, 0 days. Thomas, are we trying to find security issues for a company? No, we're not. We're doing what is called in the industry a pwnable, or it's like kind of, this one isn't a capture the flag challenge, but it's similar to what we call, gee, this light is incredibly blown out. There we go. It's incredibly similar to what we'd call like a CTF challenge. It's a small binary that is intentionally vulnerable to a memory corruption bug. So it's parity. It's kind of like a crack me, isn't it? I think crack me's are more about like reverse engineering, like trying to write, like the name suggests, a crack for it, like you would back in the days of breaking copy protection. This is more of an exploit me or a pwn me. So just a really, really small binary with a bug in it that we're trying to exploit. So it's not looking for a company. It's more like doing a Rubik's Cube, because we don't get out much, do we everyone? Gekem, good call otherwise. Smashing that LS was a good idea. Just won't work for us. So we'll continue to target the writable area of memory. And instead of ABCD, we'll put SH there, right? So we'll just quickly run that change. Breakpoint, continue. Examine our string, and we now know where there is an SH in memory. We can pretty much call system on that and be done with it all, hey? So we know SH is at the writable area of memory. What do we want to do? We want to eventually call... We eventually want to return to system. All right. Before we do that, we need to set up, it's RDI, isn't it? RDI is the first argument. Yeah, RDI. We want to set up RDI to be a pointer to sh. All right, because we're returning to system. System takes one argument, which is something that gets passed to ship minus C. So we only need to populate one register. It needs to be with the pointer to sh. So we need a pop RDI. Here's our little grepper across our gadgets. There's our pop RDI ret. Beautiful. Pointer to pop RDI. It's not at all looking pretty. That's looking pretty. Got a pop RDI ret. So buff plus equals pwn.p64. Pointer to pop RDI. It's an OJ, is it? It's an OJ! Dude, so good to have you here. So good, welcome. OJ, we're fixing my silliness from the last stream, which was only just a short 12 months ago. But we overly complicated our ROP chain, and now we're making it good. We took that ROP chain out, we're putting a better one in. So we've got sh just where we want it, at that writable location. We're going to pop into RDI the address of that sh that we went and put there, and then call system or return to system. We don't need this dead beef decaf bad anymore. Cross our fingers, hey. It should work, but we'll see. We'll see what goes wrong. Invalid stack pointer address. Couldn't get registered. Oh no, we've got a syntax error. That's what can go wrong. Pointer to system is not defined. That's because I called it the pointer to system at the PLT. That didn't just happen. Now this should work, now that the Python's correct. So we've hit our breakpoint on the ret. Let's actually step through this bit by bit and see what's going on. So we're about to ret to our pop R14, pop R15. And there they go. So now we've gone and put into R15 sh, and then a bunch of nulls. Into R14, we've gone and pointed R14 at the writable section in memory. If we go next instruction, now we're at the moving of sh to the place in memory where we know it's going to be, which will help us get around the headache of ASLR and the stack not having been a predictable address for us. And we've done that. Now if we go and do that examine one string again, we've got sh in memory. Actually, you know what? Here it is. R14 is doing it beautifully. R14 now points at sh. So now we're going to do another ret. So we'll go next instruction. Now we're popping into RDI. We're going to pop the point to sh into RDI. And then we're going to ret to system at PLT. The command we want to run is in RDI. There it is. Oh, sorry, RDI points to the command we want to run, which is sh. So if we just let this run away on us, bad things happen. What just happened? Oh, dude, that wolf, it's such a nice view. Just don't go OSINTing where I live now, please. Okay, thanks. Yeah, there it is. Yep, someone had to. That's it. All right, next stream, the window's getting shut, so none of you can see out of it. That's what this is. You are why we can't have nice things. What just happened? So shit got run by the looks of it, and then it exited with code 0177. And PwnTools saw an end of file. What is going on? All right, another time for a quick 5-minute break. Get yourself another iced tea, and we'll reconvene in a minute. Back soon. Alrighty, we are back. All right, chat. Quick real talk. Very funny on the pointing out my windows open. What is happening here? My microphone stand is drooping. That's what's happening here. Looks like we successfully ran. We systemed our sh, but it tore itself down real quick, which I'm not 100% sure about. Only acceptable docs are the ones you write on your code on GitHub. Not sure what you mean, parody, but okay. Documentation on the code is bad or good or whatever it is. Volko, enough. No more joking about doxing as well. Foot is down. No more mention of doxing. So shit looks like it's tearing itself down pretty quickly upon being spun up, and I don't know why that is. I mean, we've got PwnTools here in interactive mode ready to catch the sh, so it shouldn't be because it's getting end of file. Back to the get system jokes. Yes, please. Multi, to right. Exit code 0177. Let's quickly just step through that again, hey? Why not? Here we go. So we've got a ret to system at PLT and RDI. RDI is the register, right? x64 calling convention. RCX on Windows. So Linux uses sys5 AMD64 ABI. Yeah. So RDI is our first argument and only argument to system. So RDI points to sh, but our system of sh is not happy. What if we system ID? What happens? Not happy. What if in GDB we go, is it set follow fork mode child? And let it run. It's still not happy, is it? Do you need a full path? I don't think you do, Geckham. And do you have a return from system? You should get it for free, right? Follow from child default. Follow from mode. Follow fork mode defaults to child. Cool. Thanks, OJ. So our little tweaking there did nothing. Geckham, do we need a full path? Let's try that. Bin sure. And let her run. Nah, we still got our end of file. And inferior 2 tore itself down straight away. Yeah, I know, right, Volko? So it's wrapped in shirt -c anyway. We're not breaking anything important with our choice of writable area, are we? This is our choice of writable area here. I don't think we should be breaking anything with that. Let's go next. Let's do the right and then do the telescope again. Yeah, so bin sh tucks itself in nicely between these two existing keywords here. OJ wants to be stepped through the ROP again. So I'm not necessarily asking for spoilers just yet. But certainly, OJ, let me step you through it. Cynic, dude, good to have you around. Lord Parody, are you trying to break on the exit? No. No, I'm not. Okay, OJ. So here is the return to the smashed save return pointer. Here's my chain. So we start off with a pop ret to populate 14 and 15. Pop ret. Then here's our useful gadget, which moves what's at R15 to where R14 points. So if we examine one string at $R14, empty string, if we go next instruction, we now get bin show. So then we ret to a pop RDI to go and pop the address of where we just wrote our bin show into RDI, getting ready for the system. So next, here's the pop, and then we're going to ret to system at PLT with RDI being a pointer to bin show. Hopefully that's given you the insight you were craving. Parody says, error 0177 is a bad reference to exit from what I can see from a quick Google. Bad reference to exit. I'm not 100% sure what you mean there. Exit code 0177. What do we get? GDB giving weird error. What if we just take GDB out of the equation real quick? Did I close my Vim? Anyway, must have. If we just take GDB out of the equation real quick, so we've got a send line of buff, and we've definitely got our t.interactive. Segfault. So we're getting a seg fault when GDB is not there. You need a valid return address on the stack. System should block until child process exits, right? Which is probably why we're getting the crash when GDB is not there. Because we're running the shell, and I'm trying to throw ID down its neck. Then it's doing this exiting with code 0177, and then the parent is crashing. Because system does return, yeah. Yeah, system returns. Control back to the program. 0177. Yeah, I don't think we should need anything on the stack after. We don't necessarily need anything sensible. Once the system hits, as long as standard out and standard, as long as standard in is not being taken from us, but I don't think we are having standard in. So stood out and stood are getting probably unbuffered here. So we're not. Let's go pwn me. Does the F gets. So we're not having standard in closed or anything crazy like that. Curious, very curious. I mean, you can try running bash instead, but if my box's shit is broken, then really everything should be broken, shouldn't it? And bash also didn't want to do it. Do I have shit on my system? I think if you don't have shit on your system, Matt, well, a lot of things break. Because, for example, system, right? System is really just a wrapper around sh minus c. Wish sh. Yeah, I got a user bin sh. It's a symlink to dash, but I got something there doing it for me. OJ wants set follow fork mode parent. Thomas keeps on hearing shit instead of a sh. Fair. Sh should be defined in Etsy shells or something for when it's not the simple sh. Yeah, interesting. Okay, OJ, what I'm going to do is I'm going to go bin sh for what I want to system. And OJ, I'm guessing you're happy if I let my break on the vulnerable ret happen and then do it. Set follow fork mode parent. And then I will continue. Do system crashed. OJ says, aha. Well, do system is crashing on its ret and there's a whole bunch of Zs there. I need another writable address. Well, do system's crashing on a ret. It's trying to ret to some of my Zs. OJ, let me just go and put my dead beef decaf bad back at the end here. Buff plus equals pwn.p 64 oaks dead beef decaf bad. Set follow fork mode parent. Continue. Yeah, so it's just like shit is winding itself up straight away. And the parent process is obviously stumbling onto the next, garbage thing on the stack. But really, I mean, it's not elegant. We don't have any sort of sense of process continuation, but systeming should let me do my business, and then I can type exit and let everything burn down around me, right? Like I should get a bite at that apple. Shove exit in there. Again, I would have thought system would have blocked, or not air quotes, blocked until I did my business. But all right, pointer to exit it is. I don't get a pointer to exit. The the binary doesn't link to exit, doesn't call exit unless I can scavenge an exit from somewhere. Hey, Ozjock, I'd say it's nice to have you here, but so yeah, I don't have an exit in here anyway. I'm just kidding. Good to have you here, Ozjock. Parody says, do LDD binary names, see if your linking is good. Gladly. LDD of write4 64. I got everything it craves. Crazy idea. What if we bypass all this ROP chain bizzo and literally just ret to useful function, right? Because we know that it does a binls for us. Do I need to like fake a stack frame or something for system? If I'm going to just ret to system on x64, I don't need to go and make things pleasant for it, do I? As long as I've got the registers. Because it will do its own, push RBP. It'll do its own enter and leave. That shouldn't be it. Pretty sure that address is an issue. Yeah, that's what I'm starting to think so too, OJ. I've picked probably like the worst writable address. If that's what you mean. I'm thinking I've picked a bad writable address, but anyway. I'm going to just, for giggles, get rid of everything from my ROP chain through to dead beef decaf bad. And I'm going to go pointer to run ls or system ls. Actually, you know what? Useful function, let's call it useful. Pointer useful function equals copy address. What if we just ret to there? Will we at least get an ls going on? Tone.p64 of pointer to useful function. Forget the ROP chain, forget writing what where. Do we at least get an ls? No. Is there something wrong with my system? Sorry, not system the function, system the Docker container. How do you integrate your system clipboard with Vim inside tmux? Mine never syncs. Volko, what I do for that, Vim, this is a document of things. If I wanted to yank document of things to my system clipboard, it's double quote plus yank, I think. Paste, there you go, document of things. So it's to do with like yank buffers. I don't know how yank buffers work. I just learnt the magic Vim incantation to yank to my system clipboard. And when I say system clipboard, I don't mean the middle click one. I mean the Control V one. I'm sure there's a separate Vim yank register for the middle click paste buffer. Yeah, double quote the plus yank, I think it is. Double quote plus, no. Double quote plus, yeah. Double quote plus yank. There you go. Vim has a notion of registers. There you go. I should have just said OJ, can you get that one for me? OJ used to be a developer, so he knows a lot about Vim. So even like my return straight to the useful functions, not giving me a systeming of ls, which is very concerning. I'm gonna take GDB out of the equation again. Like this segfault here is fine because we know that once ls returns, the process will try to return to garbage. But my brain is broken now. I did rebuild my Docker image with all my tooling in it probably less than a week ago. Has there been some change that has broken abuse of system? Has libc implemented some sort of defense against return to system? That's, call me crazy, but that's kind of where my head's going. Hey, Singularity dude, good to have you around. Console. Oh, yes. Maybe it's in my vimrc. I don't want to show my vimrc on stream because I don't know what's in it, and even if there's nothing embarrassing in it, it will still be embarrassing anyway. But dpackage -l grep for vim. Nope. Yep. Install vimgtk. It is the package that lets you run Vim as like a first-class windowed application, but it also, at least on Debian, and then I'm guessing Ubuntu and Kali and whatnot, I think it's got the magic in there to do things like mouse support, yuck, and clipboard support, yay. So OJ could be OJ is saying the vimrc, maybe you do need some vimrc magic, but I think you may also find you need vimgtk instead of plain old Vim. Crazy idea, but give that a go, Volko. There you go. It doesn't work for me with regular Vim, only gvim. Yeah, I reckon it'll be because you crave having vimgtk, even when you're doing vimming in the shell. If you've got vimgtk, it gives you a slightly more magic terminal version of Vim. Yeah, has glibc done something to prevent abuse of system? Because like, if I just return to useful function, let's step through it as well, right? Bunch of A's, pointed to useful function. Let's bring GDB back into it, and GDB will break on the vulnerable ret for us. Let's step through this. Could it be dash at wolf? It could be dash. Because system is a wrapper around sh, and on my box, sh is dash. I doubt dash would have the ability to go, I was called through an abusive use of system, and I doubt my box has a completely broken system function, otherwise I'm not sure how anything would be working right now. But it could be dash being defensive. I might have to write a small C program that calls system and have a play, and yeah, anyway. So we're going to return to useful function. So we'll just go next instruction. I'm going to push RBP, that's fine. Move RSP to RBP. Move a pointer into EDI. EDI is now pointing to binls, and then we're going to call system with one argument, binls. We go next, because I think NI is going to step over this, isn't it? So it followed the child process. Should a whole bunch of nothing, and ls should have given me a directory listing, right? I've definitely got stuff in that directory, the pwd. But ls didn't want to play the game. OJ says, are you writing your bin sh to 601.000.0? $601.078. I'm going to run last stream's horrible exploit that went about things in a bass-ackwards way, just to see if it pops. If it doesn't pop, I think we got something funny going on. Let's go and run pwn write4 64.pi. All right, so it works. But today there's something going wrong. So it is obviously our fault. I can't go and blame this on some crazy glibc thing. How could I have seen that coming? But it's actually something I'm doing wrong. What am I doing wrong? Let's go and compare this like exactly to last year's offset SRP. Yeah, same offset. And then things go weird, but I mean the offset's not wrong. Wait, wasn't your shirt in user bin sure? It was, but I also have a bin sure at Wolf. I'm pretty sure if you don't have a bin sure, things are going to go wrong. Like, let's quickly go man system. Yeah, so system is a wrapper. So glibc actually bakes into it bin sure minus c, your command, null. System returns after the command has been completed. Yes, at Wolf, like even system. Yeah, OJ's saying null is the end of P. Yeah. Status 127, is that what we're seeing? If a shell could not be executed in the child process, then the return value is as though the child shell terminated by calling exit with status 127. Where's my redux? O177. Alright, then what is O177? Yeah, it's 127. So octal 177 is decimal 127. And man's system actually has something to say about exit code 127. If a shell could not be executed in the child... By the way, if you want me to like just read man pages to you, give me a call, I'll happily put anyone to sleep. If a shell could not be executed in the child process, then the return value is as though the child shell terminated by calling exit with the status 127. Yeah, fine. So apparently a shell cannot be executed in the child process. Yeah, I know, at Wolf, right? Is RSP alright? Oh man, that is a great question. I haven't gone mucking with it, so I'm sure it probably is. But it's a fantastic question. I'm going to stick with this execution and attempt to execute ls. Like, this seems to me like the simplest reproducer we've got for this. We're avoiding this stupid write to an address I pulled out of my butt. Let's see if RSP is aligned. So while we're in useful function, RSP is aligned. Drop your Zs. It's a great point. Zs are dropped. Something I probably should have tried earlier. Good call, Geckham. Oh, I think that's different. Oh yeah, Geckham was away making a cup of tea and he's just blown in and going, get rid of your Zs. I think you might be right, Geckham. There's the LS. Huh. So all of those trailing Zs was causing some sort of issue. Too much data. I'm curious as to why. It's really interesting. Let's just play with this ls a bit more. Continue. Quit. Nothing. What if we leave room for the new line and the null? 200 minus 2. Continue. Still not happy. Buff tot len minus len buff. OX 200. Weird. Oh, you reckon that's it, OJ? Let's step through and see what is there. Put that back to 1. Let's put it back to its broken state. But comment out the buff plus equals. So this is with the ls gadget function being returned to. So there was a writable pointer next. But that shouldn't be what was needed because we were seeing it crash when it tried to. Hang on, what does it look like when we call something? If we were to actually call useful function, at the time of the call, at the top of the stack, there is the return pointer. So as long as it's executable. 40000A is probably executable, isn't it? Do we need an executable pointer instead of a bunch of Zs? Let's just try going and jamming 40000A before all of our Zs. This might still be some sort of glibc protection. Probably not, but maybe. Let's keep our Zs, let's keep our ls, buff plus equals p 64 of an executable pointer. After our, I mean, I don't know or care what it is, after our pointer to the lsing function. It ran dash, and there's our ls. And we still have all those Zs. I don't think it was the length of Zs. I think it was just that we had to have an executable pointer next. OA's new line. Ooh. Ooh. Aha. Ha ha ha. Good point. Let's make it B. Good point, OJ. And then all of our Zs. Here I was getting excited that I thought there was some sort of protection. No, you're right, OJ. If I go 40000B and then a bunch of Zs, we still end up in unhappy land. Too many Zs. Sorry, who just said env-p? Could it be the env pointers getting trash? Joss Teflon, it absolutely could. Yeah. Yeah, it could, right? Let's get rid of that. Let's get rid of all of our Zs. Oh, Jesus, I feel like a absolute egg now. So what is OX 200 down the stack? So yeah, here we've already got some environmental stuff going on. Yeah, that's probably my env-p there, right? Irregardless, respectively, what else do we have? So top of the stack's 278. I was going to go out to like 478, right? So I was like just destroying not only my... Is this my env-p? Yeah, it is, right? And then basically here is my array of char stars of my actual environment. So I was not only smashing NFP, but I was also smashing the contents of the environment. Okay, and then OJ needs convincing. How far can we take this overflow until it breaks? Let's have a bit of a play, hey? So we'll stay in our LSing. We'll come back to our ROP chain later to make sure it works. Fingers crossed it just works straight up. But we've been nerd sniped by this issue now. Instead of OX200 being the totlen, let's do OX100. Continue. So we got dash being executed. If we quit, we get our listing. All right. Let's step through that and see what we smashed. So we smashed env-p, but we didn't actually smash the environment contents. Whereas normally we'd smash all the way through to what? F38 is going to take us up to 138. X200. Something like that. What's this pointer doing? Where's he going off to? And is he important? Probably not. Feisty Noodle, great to have you here. Yeah, we're doing a little pwnable, and my head is broken because we're hitting nothing I don't think to do with exploitation issues. It's kind of like we're more in the Linux internals, glibc internals, system internals now, trying to figure out why why my length of Zs I was using before was too many. Great to have you here. So good to have you here. OJ's more of the idea that argv is getting pwned over env-p. Where is argv at? All good, OJ. I think we're all in this way. I think we're all throwing out pretty wild conjecture here. I don't think anyone's going to be thinking anyone's stupid. We're all in this to scratch our heads and wave our hands madly like the always sunny corkboard. We're all here to do this. All right, so with OX100 it lived. Let's bump this up to OX180. It broke. OX140. It broke. OX120. It lives. So OX120, it's happy. OX140, it's not. OX130. OX130, it breaks. 120 is fine. 130, it breaks. OX128. $128, it's fine. So whatever's right after that bunch of Zs in this case is valuable, and when we smash it, things go wrong. Show amendment 120. Crash dash dash bisect. What's going on? What is going on? Is that argv, OJ? Might be arg. That might be argv, hey? Print argv, hey? Print underscore argv. GDB print argv address. Info var argv. Info var argv. Nope. Print at argv. Nope. Print argv 0 at argc. Print libc argv. Info args. Print underscore libc underscore argv 7ffa. Is that on the stack? Yeah, it is. 476 48 f88. I'm not seeing it. It's a bunch of Zs in its current state. But its current state, things are happy. Is it because argv at least needs to be a null terminated array? Otherwise, something was running off into the sunset. Now do info var envp. Info var libc envp. What am I hacking on? I'm hacking on a ROP Emporium challenge. OJ quits. Is it because I'm transcribing the commands entirely incorrectly? Sorry for the noise. No worries, OJ. I'm going to just tell you a bit further. Can't remember if I reached the end of my telly here. So parity like I was saying, but parity like argv should terminate here anyway. We've got a null pointer here. Just throwing it randomly out there. Could that be like saying where stood out is? Oh yeah, we never really figured out what this pointer is, did we? Can we like find it in memory? So F98 points at it. Oh duh, cause actually, yep, cool. What's this? It's part of something. Could you test that theory by throwing a null after all your Zs? Well, Minstrel, that would do like exactly nothing because this is already null. Be like pissing in a swimming pool, that. Right? I think it'd be like pissing in a swimming pool. I'm kind of curious now. What if we just go and buff plus equals a single A. Why don't we go and just chuck a random A into that pond? Oh no, there he is. Hang on. Oh yeah, we went and smashed what was a pointer to a null. Ah, Menz was saying. Alright, null after all your Zs. Sorry, you're right, Menz. It wouldn't be like pissing in a swimming pool because it was a pointer to a null, not a null itself, wasn't it? Pretty sure it was. Pretty sure it was a pointer to a null. Yeah, no, good call, dude. Oh, I give up. Slightly breaking that pointer still had things be good. 8 times 8. That breaks it. 8 times 4. That breaks it. 8 times 2. That breaks it. 8 times 1, and it's still happy. What is it about this pointer that chucking a single A into it? No, that breaks it. Alright, now I'm going crazy. Putting a single A into whatever that pointer is sometimes breaks it, sometimes it doesn't. So here we are and we're fine. Menz OJ, can you please check out what auto mod's unhappy about? Yeah, we were meant to be doing ROP tonight, but you know what? Let's quickly see if our ROP chain from before was working if we get rid of all these Zs and the single lonely A. And if it does, good. We solved the challenge. Thank you, Gekum, for calling out that I had too many Zs. And then we might just continue to dig into what about these Zs makes system so unhappy. Don't need the decaf bad anymore. This should be pretty much what it was. So where is writable? What is the bin sh? We write them, or we write it there. Pop the bin sh into RDI and return to system. There we go. Why did I get that LS? Let's comment out this useful function, Bizzo. And let's go ahead and not attach GDB anymore. So there we go. Okay, cool. The ROP chain from earlier tonight worked. But now we've got this very peculiar behavior. What is it that we're writing so far as to be messing up? Yeah, cool. Thanks, OJ. I might have to see if I can blow that up before it goes to YouTube. Get a nice little exactly what got blocked here. Yeah, I agree with OJ. We're not all prudes, but yeah, let's at least have a semblance of decency. All right, I'm going to take a quick 5-minute breather. When we get back, we're going to first of all, we're going to take a breather to celebrate the fact that the ROP chain worked after all. Thanks again, Gekum. And when we get back, let's see if we can get to the bottom of what's going on here, because I'm super curious now. So I'll catch you on the other side of this break. And we are back. Chat's been lively. I got a few things to address. Thomas, I love the music too. It's brand new music, and I should give the shouts. It's from Monster Cat. I used to use no copyright sounds, and while I quite like their music, I was a little bit sick of dealing with copyright strikes or copyright claims, I should say, sorry, on YouTube, because apparently some of the no copyright sounds catalog does get flagged by other labels. I think they've got remixes and stuff, and I think the remixes or the relabels or the bootlegs or something, I don't know, but I kind of didn't really want to deal with it. Monster Cat, if you chip them $5 US a month, they allow, well, I think if you don't chip them anything, you can use any of their music, but they will copyright claim your YouTube stuff. If you chip them $5 a month, they don't even copyright claim you. They whitelist you as long as you're a content creator with their music in the background or as part of like a little feature segment. You can't just go and create a Monster Cat channel and rip their stuff off for $5 a month. I think that's a pretty good deal, and I'm loving this playlist I've put together as well. So Thomas, I'm glad you enjoy the tunes. Thank you very much, Tara. I spent a lot of time over Christmas procrastinating actually streaming by tweaking my setup. I'm so happy with it now. I'm so happy with how it's all looking. I'm glad peeps are enjoying it too. Joss, we are so glad. OJ and I are so glad to be back. I speak on behalf of OJ without his blessing, but it is so good, at least for me, to be back streaming again. And Joss, you said execlp might be trying to parse the environment variables. We'll have to look into that, won't we? Very good catch. Cynic's off to bed. Good night, dude. So good to have you here. Our cat, first time on your stream. Welcome. So good to have you here. The last thing I wanted to address, I think, was Dover said, are you supposed to hack the program over the network, or what is the input? That is a really good question, and something I kind of took for granted and just glossed over. Okay, so what is this program? Just to get a little bit of context, it's a ROP Emporium challenge. So ROP Emporium is a collection of binaries, 32 and 64-bit, that kind of help you level up your ROPing skills. And as we've learned tonight, I need a lot of help leveling up my ROPing skills. So they're not CTF binaries, they're ponables. They're teaching ponables. How do they work? Well, at least how does this one work? So write4, if we go to the main function, which is in a C-based program where the execution starts, what do we see? We see two calls to set vbuff, stood out and stooder. And we can probably, we should parse these and make sense of them, but I can tell you now that set vbuff, this is almost certainly to unbuffer stood out and stooder, because buffering with ponables can cause some grief. And OJ, I think you recently had some grief, didn't you, with binaries buffering their output. Good on you, parody. You can sleep when you're dead or when you're back at work, hey? And really, what's the difference? Yeah, so the first two things that happen are set vbuff is called to very, very kindly unbuffer standard out and standard error. Then we get some putses, which is just a banner. Write4 by ROP Emporium, 64 bits. It prints those as a banner, that's nice. And then it calls pwnme. What does pwnme do? Pwnme does a memset, and memset is probably zeroing out something. It's probably zeroing out var28, OX 20 bytes of it. How big is var28? var28 is OX 20 bytes big. So memset is almost certainly, without parsing these, zeroing out some memory. The pwnme function is then doing a puts just to print a message, and then it's printfing a greater than space without a new line to give us this very cute little prompt. So it's printfing that. I promise you there's method to my madness of explaining all of this at the very micro level. How long did it take me to learn that? Assuming MyRCat, you're talking about what I'm going through. It's just one of those things you kind of pick up. It's kind of like the Matrix. You stop seeing code, you start seeing blonde, brunette, redhead. After a while, you look at this and you start going, oh yeah, as probably, if we wanted to, we could dig into this and have a look at how the registers are being set up and the function signature of memset and what it does to find out that it's actually zeroing some memory, but it probably is, and I'm lazy. Puts, printf, you just learn eventually that like printf doesn't print a new line, so it's useful for giving these nice little prompts. You just kind of pick these things up as you start to pull apart more binaries. Then what we do is we call an fgets, and this is where the magic happens. We're fgetsing to var28 OX200 bytes from standard in. Then after the fgets, we return, and here is where the buffer overflow happens, the stack buffer overflow, and then the ret we get control. So that's all this program does. It's actually wired up to print banners to standard output, and then read data from standard in. There's no networking code in this binary. But a lot of CTF binaries do look like this, where they interact over standard out and standard in. In which case, on the challenge, you'll normally hand this binary out to contestants to analyze, reverse engineer, and build an exploit for in their lab or on their workstation in their VM. And it's really nice to work with it. Working with a C program that takes input over standard in and prints stuff out over standard out. And as soon as you execute a shell, and the shell inherits that standard in and standard out, you can just interact with it. It's magic. It's a really nice place for contestants to be. They don't have to read and parse and go, oh, that's all the networking code, I'll ignore that. And where is the accept? And okay, that's where I start to take over. And where is the recv? You're being really nice to your contestants when you just use standard in and standard out based functions. But of course, you don't get networking. So what does the challenge server do? The challenge server will do netcat-e and will run the binary /write4_64. It will listen verbosely on the port 31337, something like that, right? That's not the port I wanted you to listen on. That's not the port I wanted you to listen. Oh, there's too many threes there. LVP, there we go. The challenge server will do something like that, and a contestant will then netcat to the challenge server on port 31337, and then standard out goes out over the network, standard in comes in from the network, and the contestant can go and interact with it and do whatever they want. Probably not the case that the challenge server will actually be running netcat. That's a little bit of a sloppy way to host it. In the past, when I've built challenges, I've hosted them with either systemd or systemd or xinetd. Those are two system daemons that you can say. Well, systemd is a lot, but xinetd is basically you can say, hey, xinetd, I want you to listen on port 31337, and when you get a connection, fork yourself, run this binary, plumb it up to the person that connected, let them do what they want, and immediately start getting ready to accept another connection. So multiple people can exploit it at once and rah. At Wolfsand, wrap in SOCAT. Yep, you can do some magic with forking and whatnot with SOCAT as well, or xinetd. There you go. So I hope that's a very long-winded answer, Dover, as to how a CTF works, the sorts of binaries you work with, why a binary that operates over standard in, standard out is nice to hack, and why, and when it comes time to wiring it up to the network, you use a naive netcat on the server, or SOCAT, or xinetd, or systemd to actually basically plumb it up to the network. Yeah, I think I recall that happening to @Wolf. I think I've struggled with that before. What about hosting challenges in containers or Docker? Brilliant way to do it. I've never had to run infrastructure as Docker in anger. I use a lot of Docker, but I do it on my workstation to run things locally in a VM-esque environment, or a VM-esque fashion. I think containerization and Docker is awesome on the host. 2019, year of Docker on the desktop, and also in an infrastructure sense, but that's not a challenge I've yet had to solve myself. And if I had to run infrastructure with Docker, maybe I'd change my mind. Maybe I'd think it's really even more awesome than I think it is already, or maybe I would not think as much. Yeah, there you go. Atwolf has done. Atwolf can talk about hosting CTFs. I think you've paid your fair share of blood to the CTF infrastructure guys, haven't you, Atwolf? Alrighty. Why is this breaking? Why is my that shell worked? That's great. Let's go and take the ROP chain back out. The Zs are still out. Let's go back to LSing. I think that's a nice simple reproducer. Now the LS works. Put our Zs back and put our single A back. With that single A, sometimes the LS fires and sometimes it doesn't. So whatever damage we're doing to that pointer, sometimes damaging it with an A is fine. Sometimes damaging it with an A is not fine. I wonder why. Let's run it with GDB again. But I think OJ said he's running this locally and seeing diff stuff too. Execl's last argument is a null because it's a var args function and the null indicates the end of argv. Okay. So it's not NFP. Sorry for misleading. All good, dude. All good. Did I learn this stuff alone or did I have a mentor? If I had a mentor, do I know where you can find one? I wouldn't say I had a mentor, and OJ might be happy or sad about that. I certainly, OJ's a good mate of mine. And while I was going on my learning journey, and OJ will gladly remind anyone about this, I used to say, I'm not a binary guy. I do web apps and I'm not into binaries. I can't do it. And he basically called bullshit and said, you'll learn. So I just did it. Like the Shellcoder's Handbook is a good book to read. What other material? Like Practical Reverse Engineering is a good book to read. There's a couple of good books. Apart from that, it was really just doing CTFs and reading CTF write-ups and doing pwnables and reading pwnable write-ups. Maybe it wasn't the most efficient way to learn. It was slow going, but it was fun. It was fun going. And I'd certainly bounce ideas off OJ whenever I got stuck. Hacking the Art of Exploitation, that's another good one. Yeah, there you go. So maybe OJ was a bit of a very hands-off mentor telling me I can do it, and I did it. Do I work with this for Paycheck or web dev for Paycheck? A lot of differing sorts of AppSec for Paycheck, mostly AppSec to do with web stuff. Sometimes it's even bordering on architectural. Rarely is it stuff like this. I mean, hacking C programs isn't like this. This is trivialized and made artificial to the point of it almost being funny when it comes to real world binary hacking. And OJ is right. I'll also code HTML for food or stickers. But I'd say most of my day job, most of my bread and butter is web AppSec. My mobile data is problem and buffer. Will it be recorded? Absolutely it will. It is being recorded. You made me double check there, but it is being recorded. It'll be up on YouTube in the next few days. I'm going to try my hand at editing the video to get rid of the commercial breaks or get rid of the BRB breaks. So it'll be a couple of days, but it will be up on YouTube in the coming days, I do promise. And the YouTube link is down below somewhere. There you go. Lord Parody, YouTube links are below. You do not understand what is going on. Am I retarded? Absolutely not. Actually, let's not use that word either, everyone. This is another, and we're kind of laying down the rules tonight. That's not cool. Not cool to call yourself retarded or anyone retarded. That's just not going on, especially not in chat. But this is hard stuff. This is hard stuff to spin up on. So don't beat yourself up if you're not getting it or not grokking it straight away. It takes some time. I hope I'm going through it methodically enough to kind of share some insight and share some knowledge and help people kind of start to really getting the lay of the land and getting your head around kind of some of the basic shapes that go on in binary exploitation. And so hopefully kind of slowing down does help some people start to build that mental map of the landscape. But welcome, dude. And OJ, bang on. Please join in. Please ask questions. What we all get out of this is the sum of the questions asked and the banter had. So welcome. Please feel at home. And by the way, we're not really in exploitation land here. We're down a rabbit hole of going, why does this A sometimes break things and why sometimes does it not? Because I'm super curious now. That's right, I was going to run it with GDB attached. Excuse me. Telly 200. All right, so here is my pointer. 4-1 has gone at the end. So there's a whole, it is, even with that 4-1 at the end, it's still pointing to a bunch of nulls. So maybe this will be one of the times at which things don't break. We've maintained the fact that this pointer points towards nulls. And there's our LS. I reckon once we finally get it to trip over itself and the LS does not work, we will find that we have damaged the pointer so it points at not a null. That's my hypothesis. Let's see how we go. And if that's true, that we can then start to dig into what that pointer is and why breaking it causes so much pain. So here is our damaged pointer. What does it point at? It still points at null. I reckon it's going to be fine. There we go, it's still fine. That worked. Telly 200. Here's the pointer. Examine AX at that address. It's actually an unreadable address now. I reckon it's going to break. I reckon it's going to break. And there we go, we didn't get dash popping. So is system trying to read that pointer, or is fork reading it, or the thing that comes after fork, the exec reading it? OJ's off. Are you saying that once we get here it's going to be good fun, are you? Got some work to do, have to bail, hand the banhammer back to men's. OJ, thanks so much for dropping in. Thanks for the insight you shared. So good to have you. And yes, I too am looking forward to your stream tomorrow, OJ. I'm looking forward to it. What is it when you don't overwrite Geckham? If I recall correctly, Geckham, it points at a null. Points at least one null. It's a great question. We can check it out. So I'm just going to get rid of that lonely little A that was doing the damage. Run it again. Telly 200. Yeah, so it's a pointer to at least one null. Bunch of nulls. But I'm guessing it's probably just the first null that actually matters. It's a great question, Geckham. What are we trying to do here? Welcome. We successfully fixed a inefficient ROP chain from the previous stream, which is only 11 months ago. But we started coming across a different issue. And then Geckham kindly pointed out my issue was that all these Zs was probably doing damage. I used to have more than this Zs, and we bisected it, binary searched back to the magic number of OX128. If I got rid of that there, and put my original ROP chain back in, everything was fine and dandy. The exploit worked with the ROP chain, with the more efficient, elegant ROP chain than the old ROP chain. We took the old ROP chain out and put a new one in. But now I'm kind of, and everyone else is scratching their head going, why does this break it? Why did Justin lose like 45 minutes of his life to this overzealous scribbling down the stack? Why does this one pointer in particular matter so much? Because system shouldn't care, right? System should just pop shell and away we go. So we're just kind of digging in and playing around. Is that the first argument? Is it argv? Gekem, that's a great question. Maybe that's why OJ is saying it's lols, because it is argv all along. It's a great question. Let's leave the Z's, but take away the A. And how does pwn.process work? Python 2, import pwn, help pwn.process. So argv is a list, but I'm setting it to a string, and pwn-tools is doing magic for me. So if I set this to be a list, BBBB, maybe you're right, Gecko, maybe we'll see that after all those Z's, there's a pointer to BBBB, in which case, yes, OJ was right all along, it was argv. It's a pointer to new line. No, it is a new line. It's not a pointer to new line. WAT Telly 200. Let's get rid of some of these Z's and see what was there that we're smashing. I'm going to just do a cheeky little -8 up here. Fix it up later. Am I overwriting too much now that there's an arg? Good question. Telly 200. Int 10 maybe. Good idea, C. I'm not too sure what's going on in Gekem. So the BBBB is still there at this stack address, EEFE8. So way down the stack actually. You know what? Let's not be monsters about this. Let's actually not do any overflowing at all and find out where the BBB lives. I broke it. There we go, buff is empty string. So we're at our ret. What are all those Z's doing there? No, go away, bad. All right, now we're sending like no data in. Find BBBB. And now let's find this. So this is what a program normally looks like. We normally got one BBB in memory, and we got one pointer to it. That's what we normally have. Let's go back to our very aggressive smashing. I'll get rid of this -8. So we're back to our ls shenanigans. Let's see if we still get one BBB and one pointer to it. Because if we don't get a pointer to it anymore, then yes, we have corrupted it, and maybe that's causing issues. But if not, I don't think we're doing anything to do with killing argv. Find BBBB. Find that. No pointers to it. Interesting. But it wasn't a broken one anyway. You know what, I'm gonna do minus 16 here. I'm gonna do minus 32. Give ourselves 4 keywords of breathing room. And see if it's in there that we can see a pointer to BBBB. Find BBBB. Find that pointer. Yeah, we do have one of them. Telly 200. So there we go. So right before the environment block, Gekim, you're right. That there is argv. It's an array of pointers, null terminated, and when we smash that to something non-readable? No. Yes, if we make that be a pointer to something not readable, maybe that's what's causing brokenness. Let me just noodle for a minute. But I mean, surely any sort of systems reliance on argv, back when these were Zs, let alone this one having a breaking or not A in it, surely those being full of Zs and thus being non-readable pointers, that should have caused brokenness, right? Yeah, if it's not null, let's wind back a bit. Let's go back to where we were like 20 minutes ago. No, let's subtract 32 from this still. Telly 200. So that is argv there. A null terminated array. Hang on. Didn't that used to be a pointer to null? Not null itself? I probably screwed up entirely. I was probably thinking this was that this stack slot was a pointer to null when it was null all along. But then why did A sometimes break it, sometimes didn't? Was that nature's ASLR and stack alignment? Hang on. Does this binary align the stack frames? I don't think it does. Ooh. Ew. Ew. Huh. Okay, I think it is argv related in some way. And the reason why an A sometimes breaks things, sometimes doesn't, is not because sometimes the A doesn't or damages something in the right direction, but here we've actually got inside underscore start, which calls main. We've got RSP being ANDed with FFFFFF0. Is it abusing pi to fake SLR? No, I don't think it is parity. This here, I think this is for why does GCC, or why do compilers stack a line on a 64-bit process? I think it might be like SSE related, maybe like it's something to do with like that or the floating point. Yeah, like I think it might be SSE line stack. Calling convention in x64 requires the stack to be 16 bytes aligned before any call. Not a hardware requirement, but a software one. Provides a way to be sure that when entering a function, the value of the stack pointer is always 8 modulo 16, thus permitting simple data alignment and storage reads from a line like. So I think. No. No, it won't help CEH. So parity, it's not faking ASLR. This is actually a compiler thing. A compiler often puts in a cheeky little anding the RSP to clear out the bottom 16 bits of the stack pointer before too much gets happening. And then from there on, all of your sub RSPs will be 16-byte aligned, so that your stack pointer is always ending in a 0. And I don't think it's going to cause any crashes or anything if it's not. I think it just means that CPUs have better performance. I think it's an optimization for the actual blob of sand on the chip. Hey, what are we up to? Right now we're wrestling with, we've gone right down a rabbit hole trying to figure out why sometimes this crashes, sometimes it doesn't. We've exploited it, but now weird stuff's happening. So here's our little A new line. I'm curious if it will always be will it sometimes butt up against argv and sometimes be one back? If so, that might explain like the flip-floppiness we were seeing. Okay, so it's still the same spot as before with regards to argv. Oh, that's not going to help us. Tele 200. Nah, it's making a liar out of me now. I really am starting to feel like that. Tele 200. Yeah, nah. This wasn't it at all. That or I'm losing a lot of coin tosses in a row. Yeah, no. I don't think it's to do with this ending of RSP. But I'm not convinced. So where are we even at now? Okay, let's rewind this a bit. Get rid of that minus 32. Let's go back to the crash, no crash zone. So we've damaged a pointer, like, hang on, log name equals Justin. Hang on. Is log name equals Justin the first thing in the environment? No, it's not. So what we're damaging is this here, the SSH ask pass. So the very first thing, the very first pointer in env, right? Let's wind this back to just -8. So SSH ask pass is the first thing in my environment. That's fine. So this here, this should work till the cows come home. We can smash, we can obliterate. Yeah, this is making sense. This is making sense as to why OJ corrected himself before. Where was he? It's hitting the bottom of the rabbit hole and it's lulls. Execl's last argument is a null because it's a var args function. The null indicates list of argv. And there it indicates the end of argv. There it constructs proper argv write4. So it's not the env. So when you system stuff, of course, when you system something, it inherits the environment. And when you do a system of ls, what happens is sh minus c ls. Sorry, bin sh minus c ls. And bin sh probably cares a lot about what its environment is. And if any of these here are illegal pointers, it probably crashes a fiery death. But if they're legal pointers, regardless of whether they point to nulls or not, that didn't even matter at all. It was just that they had to point towards something readable. If any of these are not readable, then you'll hit this case, which is what we were seeing in Xcode of 127, where a shell cannot be executed in the child process because the sh that is wrapping your ls, or the sh that is wrapping your sh when you're trying to pop shell, is so upset and so disturbed by having an illegal environment because one of the elements in the env array is an illegal pointer. It's like, I'm not starting. I'm a shell and I could not be executed. So the return code is going to be as though the child shell terminated by calling exit with status 127. I reckon that's exactly what's going on. So this here is going to work until the cows come home. Yeah, there we go. So if we just go and quickly take out the GDB attach. Like, yeah, these LSs are just going to always work, 100% reliable. I think I've proven that point, and I was proving it to myself, if anything. But if we get rid of this -8 and smash a single, if we go and poke a single A into that first element in the environment env array, we're going to see unpredictable behavior. So that failed. That failed. That passed. That passed. That passed. That failed. So it's in a sample space of 6, it's 50-50. And I bet the times it's failing, it's got nothing to do with pointing to null or being null. I reckon it's being legal or illegal pointers. Sorry, I've just kind of lost track of chat while I've been having revelations here. My mind's exploding and I'm kind of getting a little bit selfish. Hopefully, if there's anything in here that people need, they'll shout out. Parody, I don't think it's Z shell. Maybe it's... No, I don't think it's Z shell. System should be running sh, regardless of me having Z shell, but good question. What text editor do I use? It's Vim. How to learn any of this? The call-in tutorials. Yeah, I was going to be selfish and do self-promotion. If you want to learn exploitation on Windows, first point of call I'd say would be the call-in tutorials. They're amazing. But as well as that, on Windows, I've got the do stack buffer overflow tutorial. But I don't claim to be as good as call encoder's stuff. So this PDF here, the tutorial, and it comes with a pwnable that you can run yourself. I think it's quite good if I do say so myself, but otherwise you go call in tutorial part 1. He'll walk you through doing it against like real software, like terrible little 2000s era MP3 players and stuff. And he goes into way more detail than I go into, so I do implore you to check out call encoder's stuff. You know what, I'll just go and drop this in chat as well while I'm at it. If you're looking for Linux stuff, I quite like Louis' stuff, but he had to move it because I think he lost the domain name. Where has Louis gone and put up the new exploit? Aha, exploit.education. This is basically where I'd go for some pwnables for Linux. We're doing ROP Emporium at the moment. ROP Emporium is quite nice, but it's ROP specific, whereas these VMs will take you through memory corruption exploitation on Linux, and it comes with some ISOs. So I'm pretty sure this is Louis' project, right? Like sniff, I think so. Anyway, whoever did it, it's amazing. Yeah, so when we do this right, like we're getting unpredictable behavior. Like sometimes it works, sometimes it doesn't. And I reckon the times that it doesn't work is going to be because we've got an illegal pointer at the top of the environment block, or the top of the environment array. So let's go and reattach GDB. And as long as I get a couple of hits on this theory, I'm going to call it a solved problem. Telly 200. Examine a string there, and it's an empty string. I reckon this is going to work and give us ls. Hooray! Correct. Telly 200. Is this a valid pointer? No, it's not. I reckon this is going to not work. Hey, there we go. Let's just get a few more confirmations of my crazy theory. Examine one string there. It's a broken pointer. I reckon this will not work. Hey, it didn't work. One more. Telly 200. And this is a valid pointer, so I think it will work. And there we go. So I think that's what was going wrong. Just to make that super crystal clear, let's go ahead and subtract 8 from this. Yep. Run it and do a telescope down the stack. So this first element, you can see here, here's the lonely little A and a new line hanging out. That's the first string in the env array. An array in C looks like this. It's a whole bunch of pointers followed by a null pointer to indicate the end of the list. So this is a healthy looking env or environment array. But when we smash any of them with an illegal unreadable pointer, you know, if we just go and snipe the bottom 2 bytes, actually all along we were actually writing 2 bytes. We were sending a new line, not just A. But if writing the bottom 2 bytes of this turns this from a legal pointer into an illegal pointer, one that can't be read, or written, I don't know. I don't know what Shell expects. I don't know if Shell gets real stroppy if the environment is readable but not writable. I don't know if it gets stroppy if it's not writable. I don't know what's upsetting it, but something was upsetting it when we were getting illegal pointers through the env array. So that's what it's funny, right? Like that's what we lost 45 minutes of our life to in debugging this little ROP chain, followed by, you know, why is this not working? And then Gekem said, what if you get rid of the Zs, as he was sipping tea? We lost 45 minutes to it then we probably lost, more than an hour to it, trying to track down exactly why it was broken. But I call that a success. I think that was worth digging into. I think that was, and that's a lesson learned, hey. Like, I always kind of learned growing up that you should keep your buff tot length nice and static, or your total length nice and static, in case the program behavior differs depending on how big your input is. All right, you'd hate to kind of get 1024 A's, get a crash, with a save return pointer overwrite being returned to, an overwritten save return pointer being returned to. Then you do your metasploit pattern or your pwn cyclic, and you find the offset, and you do this, you do that. And then once you try and spike your save return pointer, if you don't have that trailing garbage, I use Z. If you don't have the trailing garbage, then all of a sudden the program behaves differently. So I was actually taught to keep this constant. I did that today, but I was a bit too aggressive. I had a few too many Zs in it, and it caused us grief. So now we know if you're doing stack buffer overflow exploitation on Linux, maybe it's something to do with x64, I don't know. Don't damage the environment block. Like, don't damage env-p, the array, and put illegal pointers in it, or you're going to have grief. So what have I missed in chat? Because I'm gonna head off in a moment. But are there good channel follow you? Thank you very much, Micha. Really good to have you here. CTF challenge where you have to replace something in this area of a system bash call. Are you hmming about something in particular? Because there is something in particular that is worthy about that, but I won't spoil that for anyone who hasn't stumbled across that person's challenge yet. But maybe that's why OJ thought this was quite lolsy. What are we doing here today? We were doing some ROP Emporium exploitation, but we're actually wrapping up now. I'm going to head off for the evening now. Gekum would have been up all night if I didn't figure it out. Well, I'm glad I can help you sleep well tonight, Gekum. Save the environment, save the whales. Exactly right. That should be the new slogan of the channel, hey? OJ's back! His ears pricked up. You had me on speakers, but you haven't been watching. Well, it was nice things we said about you, wasn't it? I think we figured it out, OJ. I figured out that when I was doing just the lonely little A, I was damaging only the first thing in env-p. And I'm guessing Shirt wants them to be readable and or writable. Singularity is ignoring me. What did Gekum is making Justin sad because he's cruel. I'm not ignoring his sin. What did I miss? Lucky. Was that to me? Aw, Sin. That's lovely of you. That was the conclusion I arrived at. OJ, do you concur? Do you concur that was causing us our grief? Please say yes so I can go get something to eat. I'm starving. Got to raid the pantry and raid the fridge and see if there's any dark chocolate in there. There's a challenge where you wrote this. There's a challenge where there's a thing and you wrote the bloody thing. Yes, you did. Yes, OJ concurs. All right. I think that's we've been dismissed. I'm going to head off. I'm starving. I'm exhausted. I'm so happy to be back. Thank you everyone for tuning in. You didn't know about that one, Atwolf. I thought you were humming very strategically. It's so good to be back. Thank you for joining me for the first stream of 2019. The first stream in quite a while. It's not really fair to say it was the first stream of 2019 because it's not like I streamed it all in the last half of 2018 anyway. But yeah, thank you very much for sticking around. Thank you for your pokes, your prods, your guidance, letting me know where I was going wrong and what I should try. I think we all cracked this together, and I'm so glad you're here to help me out. I don't have a schedule bedded down just yet. I'll be kind of streaming as the opportunities arise. So stay tuned for the next stream. Give me a follow on Twitter. That's where I announce my streams. Hit the follow button down below, and then ask Twitch through the settings somewhere to email you when I go live. And hopefully we'll catch you for the next one. But until then, hope you've enjoyed it and peace out.